Hey everyone, this is Mohammed Nadeem and welcome to my YouTube channel. Today in this lecture, we will discuss about the scientific notation. Scientific notation is the easy way of writing the large number or small number in power of 10. In this lecture, we will discuss about the scientific notation in more detail. So let's start the video with the scientific notation. So here we have the large number. It is 1 to 5 million. 1 to 5 with the 6 zeros, and I'm going to reduce the size or the space occupied by this number. So here, if for each step this their size is decreasing. So what is the scientific method behind this? So in order to reduce this number to this number, we will divide this number with 10. So if we divide this number by 10, then this one zero will be cut and it will become 1 to 5 with 5 zeros. Originally it was 6 zeros. Now if we further divide this by 10, then it will become 1 to 5 with 4 zeros. And by further division it will become 1 to 5 with 3 zeros, and by further division it will become 1 to 5 with 2 zeros. But here is the problem is this: it's okay, the size of this number is reducing, but here the magnitude is also reducing. So how to maintain their magnitude as the original? So for that, if we reduce this by 10, we will multiply that number with the 10. And similarly, if we reduce this to this number, we will divide this by 2 times of the 10 in order to retain the magnitude of this number. So we will multiply this with 2 times of the 10. So this number is actually the division of this number by 3 times of the 10. So this number will become this. In order to retain the magnitude of this original number, we will multiply this with 3 times of the 10. And similarly, here this number is actually the division of this number by 4 times of the 10. In order to maintain its magnitude, then we will multiply this number with 4 times of the 10s. So here the magnitude of this number and the magnitude of this number will be same. And similarly, this is actually the 5 times of the division of the 5 times of the 10. So here it will be multiplication of 5 times of the 10 in order to maintain the magnitude of the original number. So in this way, we are going to reduce the size of this original number. But here is the problem again. It's okay, we have reduced the size of this, but multiplication of the 10 is increased. So here the size is increased, not reduced. So it's okay, the size of this original is reduced, but here the multiplication of 10 is increasing. So what is the solution for this, for these tens? So for these tens, we know that this is actually a 10 and this is actually 2 times of the 10. So we will use the exponent, which is mean that 2 times of the 10 is equal to 10 power 2. And here 3 times of the 10 is equal to 10 power 3. And this is 4 times of the 10, which is equal to 10 power 4. And this is 5 times of the 10, which is equal to 10 power 5. And similarly, here I will write multiply 10 power 6. Okay, and here I will multiply 10 power 7, because the difference between this and this is only division of the 10. And so for that we will multiply 10. So if we multiply 10 here, this 10 power 6 will become 10 power 7. And similarly, the difference between this number and this number is a division of the 10. So if we divide this by 10, this point will be shift here. So here we divide this by 10 in order to remain the magnitude as constant. So we will multiply this with the 10. So this 10 power 7 will become 10 power 8. Now this is the compact form of this number, and the magnitude of this number and this number is also the same. And this process is called the scientific notation. Scientific notation is the easy way of writing the large number in power of 10. So we write this large number in power of 10. Now, what is the method? What is the scientific method in order to convert this small number into power of 10? So for that, we will multiply. If we multiply this small number with 10, then it will be increased, and due to multiplication of the 10, this point will be shifted here to this position, and this number will become this. So here, if this point is shifted here, then at the right side of the point there will be 1 2 3 4 5 zeros. So the same case is here. Now the point is here, and this is 1 2 3 4 5 zeros on the right side. Now the problem here is that it's okay, we reduce the size of this number by multiplication of 10, but now there is the difference in the magnitude of this and this. So what we will do here is that we will divide this number by 10. We will write here the division of the 10. So now the size, now the magnitude of these two are same. So here I'm going to further proceed this. By division of 10, we can write that 1 by 10. This is also equal to divide by 10. And we can write this, this is 10 power minus 1. Okay. So here I will write 10 power minus 1. And similarly, if we uh, increase this number 10 times more, then then for that we will multiply 10 with this. If we multiply 10 here, then this point will be shifted here. Okay, now this point will be here. So on the right side of the points, we will have 1 2 3 4 zeros. So the same scenario is present here. On the right side of this point, we will have the 4 zeros. And in order to maintain its magnitude, we will this multiplication is with this, but here we will multiply, we will divide this with other 10 minus 1 here. And similarly, if we increase, if we shift this point to here, okay, now on the right side of the point, we will have 3 zeros, and this is the same scenario. So in order to maintain the magnitude, we will multiply other 10 here. So this 10 power minus 1 and 10 power minus 1 is in its own. And during this step, we will write other 10 power minus 1. And similarly, if we shift this point here, we will multiply this with the 10 in order to maintain the magnitude. We will divide this with 10. So here with this, we have these three as it is. And for this step, we will multiply, we will write here 10 power minus 1. And similarly for this, it will become 10 power minus 1. This is 1 2 3 4. So here will be 5 times of the 10 power minus 1. Multiply 10 power minus 1, multiply 10 power minus 1. This is 4 times, and now it become 5 times. And similarly here, it is 6 times. 1, 2, 3, 4, 5, and this is the sixth time. This is power minus 1. This is the sixth time. Now again, it's okay. We reduce the size of this number. Okay, this with the yellow color, this size is decreasing. But here, this size is parallel increasing here. So in order to handle this problem, we will again use the exponent. So this 10 power minus 1, and this 10 power minus 1, this 10 power minus 1 is equal to 10 power minus 1, and here this 2 times of the 10 power minus 1 is equal to 10 power minus 2, and 3 times of the 10 power minus 1 is equal to 10 power minus 3, and similarly the 4 times of the 10 power minus 1 is equal to 10 power minus 4, and similarly it will become 10 power minus 5, and it is 10 power minus 6. Now this is become 10 power minus 7. Now, this is the scientific form, the scientific notation of this number. So here, this number is, the size of this number is very large. So here we have 1, 2, 3, 4, 5, 6, 7, 8, 9. We have 9 numbers here. We convert that, we reduce the size of this 9 numbers to 1, 2, 3, 4, 5, 5. So from the 9 we comes to the 5 number, and the magnitude of this and this is also the same. So this method, this scientific method to convert this small number, to write this small number in power of 10 is called the scientific notation. So in order to reduce the size of the large number, we will multiply that with the by 10. For each step, we will multiply that by 10, and that multiplication of the 10 can be written in the exponent form, and here this is the compact form of this original number, and here this is the compact form of this original number, and the magnitude of this and this is the same. So here the chances of the error is has reduced. So further, we going toward this example. Here we have the large number. 840000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000 So this is seems as boring, and if by mistake, if we do not write 10, then it will impact on the magnitude of this whole number. So we will have to write this in compact form. So for that, we will use the scientific notation. And the process for the scientific notation is this. We will take one step from. So here the point is here now. So in order to write this in scientific notation, we will take this point and take each step. So this is the first step, 2, and this is 3, this is 4, 5, 6, 7, 8, 9, 9, and this is 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34. So we take this point from here, and we take 34 steps, and we reach here. So in scientific notation, we will write this as 8, and now the point is here. Okay. Now the point reach here. So 8.4, and how many steps we taken? 10 power 24. Oh, sorry, 34. So this is 34. So this is the compact form of this large number. And the magnitude of this number and the magnitude of this number is the same. So this is the scientific form of this regular form. This is actually the regular form, and this is the scientific form. As I discussed before, this 10 power 34 is actually 34 times multiplication of the tens with 8.4. So here it means that if this number, so let's say this 8.4 is I consider as x, and on the top of it we have positive number. This positive number is actually show us the repeated multiplication of the 10. So this time we if so this times if we multiply 10 with 8.4, it will give us this value. And similarly, if we have this number 0.000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000 This seems is boring, and we have to convert this number into scientific notation. So what we will do here is that we will take this same uh, point from here, and we will take each step. So this is the first step, second step, third, fourth, fifth, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27. So now the point comes here. So the points now in between 1 and 6. So 1.6, 7, and 3. And for each step, we write the division is here. So for each step, we take the division, and here how many steps we taken? We taken about 10 power minus 27. So here this number can be written in this form, and this is now the easy way to write. And here the chances of the mistake is less here. So the general form of this is that if we consider this mantissa is x, and the power is now is minus in minus number, so it means that it is the repeated division, mean that this times it means that if we multiply if we divide 1.673 is 27 times of the 10, it will give us this value. Okay, so this number is with minus 1, with minus sign is indicate us the division with this number. Can you direct say here that is this number is greater than this, or this number is greater than this? And similarly, we have the scientific notation is, and here we have that same scenario. We have this number, okay, and we have this number. We can't directly say that this number is greater than this, or this number is greater than this. But if we have this number in scientific notation, then we can easily say that this 10 power 15 is greater than this 10 power 14. So it gives us the convenience that if we do not directly compare the two big numbers, and if we compare that, it will take long time. So how to reduce that time? We will write that number in scientific notation. So if we write that in scientific notation, then we can easily say that this number is greater than this number, because this is 10 power 15 and this is 10 power 14. And similarly here, we do not say directly that this number is greater than this. or this number is greater than this. But if we write this in scientific notation, then we can easily say that this number is greater than this. So the scientific notation of this is that we will take this point and this is the first step, second, third, fourth, 5, 6, 7, 8, 9, and 10. So 8.9 multiply 10 power minus 10. And here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 8.9 multiply 10 power minus 11. So here we can say that this number is greater than this. And this is easily we can say here is that, and we do not say from the regular form is directly that this number is greater than this. But in scientific form, we can directly relate these two numbers. And this was about the conversion of the regular number into scientific form. So here we have this regular number and we convert that into scientific form. And similarly for the small numbers, we take that small number and convert that into scientific form. So this is that same case. We have the regular number, okay, which is which is this number, and we will have to convert that into scientific form. So here we have this regular number, and this is 47 million, mean 47 with the 6 zeros. So how to convert this into scientific notation? We will take this point. The point will always present at the last of the number. So here we will take that point. This is the first step. This is the second step. This is the third step. This is the fourth, fifth, sixth, and this is the seventh step. So we will take here. Now the point comes to here. This become 4.7 and multiply 10 power plus 7. Okay, is here. We know that this plus is actually represent the repetition of multiplication, and the repetition of multiplication is with the larger number. Okay, so here how many steps we taken to reach the points here to 4.4 between the 4 and 7. So these steps are 7. So therefore we will write that steps and the in the exponent of this 10, and this is that non-zero digits. This also called mantissa. And similarly, for this very small number, if we have this regular form and we ask to find to convert this into scientific notation, we will take that points, and this is the first step, second, third, fourth, fifth, and this is the sixth steps. So we take six steps in order to reach the first non-zero digit. So now the point is here between 2 and 6. So the point is here between 2 and 6. So this become 2.63. And now for the smaller number, if we take the steps, so here we take 6 steps. So we will write that with the negative sign. And this negative sign is actually represent as the division. So it means that if we take this number and divide this by 10 times of so divide this by 6 times of 10, then we will we will achieve this number, this original number. Okay, don't be confused here. This is the in-depth intuition of the scientific notation, and I'm going to cover this with this more detail. So here, if we have that same scientific notation, and if someone asks you to convert this scientific notation into regular form, so the same reverse engineering will be occur here. So here we have this number, and if someone asks you to convert this compact form again to this form, so we will take the reverse engineering here. So if we convert this to this form, so we will multiply here 10 with 8 times. and then we will convert this number to this number. So the same scenario is present here. If someone asks you to convert this scientific notation again into the regular form, so we will do here is that we will take that number 9.26, okay, and this is actually indicate us that if we will have to multiply 10 6 times. So we write that multiplication of 10 6 times. And so for the first step, if we multiply this with if we multiply this with 110, this point will be shifted here. And then if we multiply this with this second step, this second 10, then it will take this second step, and now point will be here. And if we multiply this with this third 10, then one step will be from the left to the right. And similarly, for each 10, we will take the one step here to the right. And now we reach here. So for each steps, so the point is now here, and now we will write zeros for each steps. And this is the regular form of this. So this has become now the point is shifted here to the last. And how many steps it has taken? So that is 1 2 3 4 5 6. So it the same scenario is present here. This point from here taking the 6 steps is 1 2 3 4 5 and 6. So this is the reverse engineering of the scientific notation into the regular form. And similar, the same case is present here to convert the scientific notation of the smaller number into regular form. So this is the scientific notation of the smaller number, which is, let's say we have 1.09 multiplied 10 raised to power minus 5, and how to convert this into the regular form. So here we know that 10 power minus 5 is actually indicate us that we will divide this 10 5 times by this number. So the same scenario present here. We take that same number 1.09 and we will divide this number 5 times with 10. So if we divide this number, let's say we have to, I'm going to cut this. So I will take this number 1.09, okay? And if we divide this with this 10, it will take this first step and will reach here, okay? And now if we divide this with this second 10, then it will again take the other step. And if we divide this with this 10, and then again it taken the other step, and similarly it will for this 10 it take this step, and for the last 10 division it will take this step. And now the points is shifted from this position to this position here, okay, and in between them for each step we will write 0. So this is 0 0 and 0, okay. Now the point is shifted here. So how so it become 1 1 2 3 4, and this is four times of the zeros, okay. We will write 4 zeros and then 109. So here is the 4 zeros and then 109, and the point is shifted from this position to here. So this is the reverse engineering of the conversion of the scientific notation into the regular form. And in this in the last, we have the simple, what we can say, examples. So on this side, we have the large numbers, and let's say 1 million is actually uh, 1 million is 1000, okay. This is 1000 and 3 times of the zeros, okay. 1000 and three zeros. It is equal to 1 million. And the scientific notation of 1 million is this. So the point is here, and we will take the first step, second, third, fourth, fifth, and sixth. Okay. So 1 multiplied 10 power 6. And similarly, 1 billion is, we will take the thousand, and we will take two times of the three zeros. It will become 1 billion. And the scientific notation of this is that the point is present here. First, we will take this step. For that, here it will become 10 power plus 1. And for this step, that will become 10 power plus 2. And for this step, this will become 10 power plus 3. And for this, that will plus 4, plus 5, plus 6, plus 7, plus 8, and plus 9. So the same, we will write that 1, okay, the non-zero digit, and multiply 10 power that 9. Okay, and similarly, 1 trillion is actually the 1000 with three times of three zeros is called is actually 1 trillion. So the scientific notation for this is we have a point here, and we will take each step. And so here, if we take 12 step, we will reach here. So that's 12 we will write, and the exponent of the 10, and this non-zero digit is precede here. And similarly, for the for the very small number, so if we have 1 micron is actually 10 power minus, so 1 micron is actually zero equal to 0.000001 meter. And in order to convert this into scientific notation, we will take this step, and this is the first, second, third, fourth, fifth, and this is the sixth. So if we take six steps, then we will reach this one. So we will take that one, and now we are dividing this number by 10. So this is equal to 10 power minus 6 meter. And similarly, for 1 nanometer, it is equal to uh, 0.8 times of the zeros and then 1. Okay, and if we write this in scientific notation, then we'll take these steps, and the number of steps we taken here is this. Okay, and this minus show us that the smaller number has become larger. Okay, this was the in-depth intuition of the scientific notation. And that's it, guys. Thanks for watching.